Today we're going to be learning statistics. Today we're going to be learning statistics in mathematics. What is statistics? Statistics is very, very simple. Statistics simply means working on data or data, manipulating data to make it meaningful so that people can understand. Is that clear? That is the meaning of statistics. It's nothing difficult. It simply means when you have a collection of data, work on it, manipulate it so that people can understand the information you're trying to pass. Is that clear? Let's say now we have data of scores of students. You understand? You come to your class now. We have Olu scored how many? 12. Ada scored 15. Shola scored 20. Obi scored 12. Adamu scored 15. You understand? If you have this collection of data and you're looking at it, are you understanding it? It's difficult for you to understand it. You understand? But when you take this collection of data, you prepare it in a table. Then from this table, you're able to calculate the mean of the scores. If you tell me that the mean of the scores of the students is 70, I will say yes, these students are doing good. But if you tell me that the mean of the students is 20, I will say, hey, people are not passing this geography again. Oh. We need to teach it very well. Is that clear? So when you now get the mean and you tell people about the mean, people will be able to understand what the information you're trying to get across. Is that clear? But if they are looking at this data the way it is, it doesn't make much sense. But when you convert this data from this way it is into a table, then from this table you can easily calculate things like mean, mode, median, standard deviation, variance. Then you're passing meaningful information to the people. Is that clear? So statistics simply means what? Manipulating what? Data into forms. I'm using it to calculate statistical parameters like the mean, mode, median that will make sense to the end user. Is that clear? Is that clear? So we say that in statistics, we study what we call what? Data collection and what? Analysis. When you collect your data, can you see this data? It has been collected. This is the scores of people in the class. Ada, Obi. What is Joshua's score? 20. What is Mohammed's score? 20. What is Adamu's score? 15. So when you do data collection, which is picking out this data, is that clear? Then you analyze it by putting it in tables like this. You understand? Then from this table you can calculate the mean, mode, median. Then you're doing what we call what? You're doing what we call what? Statistics. You understand? Statistics means what? Collecting data, arranging that data, manipulating it, and using it, putting it in form of table, in tabular form, and using it to get informations like mean, mode, standard deviation, variance. You understand? Those parameters, those statistical parameters, they make meaning to the person that gets to get the information. Is that clear? That's a statistic. So we say that data is any numerical fact. Data is any what? What data are we using here? Scores. What data are we using here? Is scores the only data that you can use? No, you can also use what? Height. I can decide to measure the height of all the students. I'll go to Ada, I'll measure the height of Ada. If the height of Ada is 1.7, I will come here and write what? 1.7. I'll measure that of Obi. If it is 7.2, I write. Is that clear? So, data is any numerical fact or information that which can be what? Measured. Is that clear? Example of data is what? Height, weight, age, mark. You understand? So once you can measure it or you can give it a numerical qualification, you call it what? Data. Examples of data are what? Height, weight, age, mark, mass is volume. The data we are using here is the what? Marks or scores. Is that clear? In statistics, these data are analyzed to get what? What do you analyze the data to get? Statistical variables like the what? Mean, mode, standard deviation, etc. You understand? In tabular graphical forms to give better meaning to the end what? User. You understand? So when you work on the data to give better meaning to the end user, you've done what we call what? You've done what we call what? Do you understand what statistic is now? Working on data. And this is data. This is what? This is what? Data. This is what? Data. Once you work on it to convert it into this tabular form, and finally in terms of mean, mode, median, and variance, we call it what? Statistics. These statistical parameters can be classified into what? Into a measure of central tendency or measure of location. You understand? You're trying to calculate average. We call it what? Averages. And you're going to find out that this statistics, you can use it not only in mathematics, you use it in data science, in computing. You understand? When I'll be taking you on, when I take lectures on Python, we know that we have what we call data science. You understand? Data analysis and visualization. You understand? So statistics is just another way of saying data science. Collection of data, working on it, manipulating it in such a way that people can easily make sense of the data. You understand? So in data analysis, what you're doing is actually statistics. What you're doing is actually what? Only that you're now using computer program to work on it. You understand? You use programs like Python, you use R language. Is that clear? So there are two types of data in statistics. There are two types of what? Data in statistics. We have what we call repetitive data. We have what we call what? Yes. Repetitive data is like, if you look at this data, you see that there is 12 here. Can you see 12? Can you see another 12? So 12 is repeating. You understand? So whenever you have data that has repeating, you can see 30 here, you can also see 30 here. Whenever you have data that are repeating, you can easily put it in tabular form, identifying the word frequencies. You understand? Frequency is simply telling us the number of times that something has occurred. Is that clear? 12. How many times did 12 occur in this data? 16. How many times did 15 occur in this data? 13. So if you count number of 12s, 1, 2, 3, 4, you count all the 12, you get 16. Count all the 15, you get what? 13. This tally is not required so much. You understand? We only use this tally for you to make it easier for you to get the frequency. Is that clear? Yes. So this tally is not very important. You're only using the tally like if you want to count 12. Let's say you didn't have this and you want to count the number of 12. If you see the first 12, you write what? 1 tally, is it not? Second 12, you write another what? 1 tally. Third 12, Abi? Fourth one. Fifth one, you cross it like this. So you know that there are how many 12s here? 5. You understand? You start again. You understand? So this is the essence of the word tally. Is that clear? Can you understand the essence of the tally? It's not as if it's very important, you understand? But it makes the calculation of the frequencies to be what? Simple. Is that clear? This is for repetitive data. For non-repetitive data like age, you understand? If you have 1, do you have another 1 here? If you have 9, do you have another 9 here? So this is a non-repetitive data. But this one is repetitive data. But you're going to see that in actual real world situation, you will always see repetitive what? Data. Because if I'm picking the data of the scores in a class or your height, you find out that one person, 2 people may have the same score, like say 55. Don't you have 2 people having the same score in a subject in your class? You have it back. So in real life, you have repetitive data. For you to calculate mean, mode, median, standard deviation, and variance for repetitive data, you need to first of all put it in tabular form. Is that clear? But if you want to calculate it for non-repetitive data, it's simpler. Now, let's calculate the mean data for this non-repeated data. Ages in a class, we have you having the age of 1, the other person having the age of 9, the other person having 9. Can we calculate this mean? How do we calculate? The mean of this simply means addition of all of them, is it not? 1 plus 9 plus 8 plus 10 plus 2 plus what? 3. All over how many times they have? 1, 2, 3, 4, 5, 6. This will give us the mean, is it not? Now, the mode, what will give us the mode? The mode is the highest score, and the highest score is what? 10. But here now, what is the mode? For a repetitive data, the mode is not the highest score. You cannot say that the mode here is 30. For a non-repetitive data, the mode is normally the highest what? Score, which is 10. But for a repetitive data, the mode is the score with the highest frequency. The score with the highest what? The most occurring score. And the mode here is what? For this repetitive data, the mode is what? 12. Is that clear? So can you see the difference between a non-repetitive data and repetitive data? Can you see the difference? You understand? So this collection of data, you have to put it in tabular form, calculate the frequency before you can be able to tell us the mode. But for this one that is not repeating, you can simply say it from there. Then median, how can we calculate the median? Median is the what? The middle number. So you have to arrange this first. So the smallest is what? 1, followed by 2, followed by 3, followed by 8, followed by 9, followed by what? 10. So what's the middle number? You have this first 2 go, this first 2 go, you have 3 and 8. You You understand? So the median should be in between 3 and 8, is it not? So it should be 3 plus 8 all over what? 2. Can you see that we've been able to calculate the mode, median, and mean for this non-repetitive data? Is it? But that of this one, it's not easy to easily calculate. You understand? First of all, you have to convert it to table, and in subsequent classes, I will be teaching you how to use this table to calculate all these measures. Measure of central tendency, measure of dispersion, measure of location. You understand? These measures are what we call statistical parameters. You understand? When you give somebody information, depending on this, then you've done the statistics. Is that clear? When you can be able to tell me the mean of the scores, because the mean of the scores tells me something, is it not? The mean of the scores tells me whether people are passing. If you tell me that the mean score for these people is 70, I'll say, yeah, they are doing well. I'll go and greet my teachers. I'll be like, oh, my teachers, you guys are trying. If you tell me that the mean is 32, will I be happy with my teachers? I'll say they are not doing well. You understand? So with the score, once you work on the statistics and get the statistical parameters or the measures of central tendency or location, somebody can easily make sense of your data. Is that clear? Now, if you tell me that the mode is 12, will I be happy with mode of 12? When you tell me that mode is 12, you're telling me that most people got 12. Is it not? Because 12 is the most occurring. I will say, hey, the score is not good. Happy? But if you tell me that the mode is 30, I will say plenty people scored 30. Can you see that? So you can see the mean is making sense. The mode is also making sense. Is that clear? So that's what we call them averages. And that is what you do statistics for. You want to be able to use the data to calculate these averages. So that with these averages, somebody can make sense of what you're saying. Is that clear? Please, if you like this video, click on the subscribe button, like and share it so that people can get it. In subsequent classes, we are going to be doing a whole lot of things in statistics. I hope you enjoyed the class. If you have any question, drop it on the comment section of this video. Thank you very much.